Hi, fourth graders. Here is our second lesson for this week before spring break. Remember, on Friday starts spring break, so you won't be getting any lessons from me until April. Oh gosh, let me look at the calendar. You won't get any more lessons from me until April 13th. So you get quite some time off. So I just want to remind you of that we won't be back to school. We won't be back to, I won't be back to posting lessons until the 13th of April. So just keep that in mind that this week, because I didn't give you any vocabulary and we're only doing, we're doing a little less work than normal. Please make sure you get everything caught up. I need everything turned in as soon as possible. I'm still missing quite a bit of work, I'm missing quite a bit of work from you two girls, from Isabella and Madison. So that stuff needs to be handed in as soon as possible because the end of the quarter is soon. And if I don't have evidence of work, then you're definitely not going to like your grades. And then that means that you're not showing me what you know. So it's telling me that you're not doing the work. It's telling me you're not watching the videos. It's telling me you're not doing what you're supposed to be doing. So please take this time to get everything turned in. Again, Thursday the 1st, everything is due. So this Thursday, all of your work is due. And then we won't be back to doing anything again until April 13th. All right, so we're going to be on Module 11, Lesson 2. We're going to be comparing fractions again, but we're going to use some benchmark fractions. And when I talk about benchmark fractions, I'm usually talking about halves and whole. So 1/2 and 1 whole. That's what I'm usually talking about. Are you less than a half or greater than a half? Are you closer to 0 or are you closer to 1? So these benchmark numbers are what we'll be talking about a lot when we're talking about how do we compare fractions, especially ones that are you can look at and you're like, okay, I know that this one's less than a half and I know that this one's greater than a half, so I know that that fraction is bigger. So that way you're not always having to draw a picture. But we're still going to be drawing pictures. But this is going to help you so you won't have to always draw a picture eventually. All right, so we're going to be able to use benchmarks to compare two fractions and then record the comparison with the symbols less than or greater than. So we have two people, Abbott and Rowan, and they go to the climb-a-thon. They both climb ropes that were the same length. Who climbs higher than halfway up the rope? So I'm going to draw one of our holes, and I'm actually going to split this one in half. This is going to be our benchmark, right? Because it says who climbs higher than halfway up the rope. So I need a benchmark fraction, and I'm going to use 1/2 as my benchmark fraction. So I'm going to shade the half of this in. Alrighty, so I can see on the scoreboard that Abbott climbed 5/8 of the rope. So we're going to have Abbott right here, and Abbott climbed 5/8. So again, I'm going to draw a rectangle so that way it's the same length, and I have eighths. So it's an even number, so I know I can split it in half, right? And then half of 8 is 4, so I need 4 on each side. So I'm actually going to split each one in half again. And then I've got 4, so now I need 8 total. So half again, and I have 1, 2, 3, 4, 5, 6, 7, I have 8. Abbott climbed 5/8 of the rope. So we're going to shade in 5 pieces. So already I can see that Abbott climbed higher than half of the rope. But let's just see what Rowan did. So Rowan climbed 4/10 of the rope. So again, I'm going to draw another rectangle that's the same length. It's an even number as my denominator, so I'm going to follow that same half line that they all have. But half of 10 is 5, so I need 5 on either side. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I need to shade in, now I have my 10, I need to shade in 4 of them. And you probably already could have guessed, right? Once you started drawing those pieces. Oh yeah, Rowan definitely climbed less than half. So this tells me that Abbott, our 5/8, is greater than 1/2. And Rowan, our 4/10, is less than 1/2. So that means that Abbott, climbed, I should have put this up higher than 1/2 the rope. So we can visually see, right? Abbott, we have our benchmark. Half is our benchmark. We can see that Abbott climbed a little more than half. Rowan climbed less than half. Okay. So the owner of a yogurt shop brings 1-gallon buckets of yogurt to the climb-a-thon. At the end of the day, one bucket is 2/5 full, and a second bucket is 3/4 full. Which bucket is less than half full? So we want to know what is less than half full. Okay? So what fractions are we going to need to compare to solve this problem? Well, we're going to need to compare 2/5, 3/4, all to 1/2. So we're going to compare 2/5 and 3/4 to 1/2. So again, we're going to have our fraction strips. So I'm going to draw. I'm going to split it in half. So here's my half that we're going to compare everything else to. So I'm going to shade that in. So I know I'm comparing everything to a half, and I want to see which one is less than half full. Okay? So let's start with our 2/5. So again, I make a bar model that's the same length. Now, fifths is an odd number, so I can't use that half line, right? So 1, 2, 3, 4, 5. So I need to shade in 2 of those pieces. So already I can see that 2/5 is less than 1/2, but let's just, because we need to compare all of them, right? We need to compare all the fractions. We're going to continue on. So now I've got my 3/4. Now I can use the half line from up here because I want fourths, and I didn't really do it right directly in half, and I want 3 of them. So 1, 2, 3. So this one is definitely greater than 1/2. So we can see that the numerator, right, for 1/2 is half as much as the denominator, right? So we can visually see that. So we can see that 2/5 is less than 1/2, and 3/4 is greater than 1/2. We're not going to worry about these. So which bucket is less than 1/2 full? It is the 2/5 bucket. And we know that because we can see that up here, right? 2/5 is less than 1/2. So the 2/5 bucket. How do you know? Our answer is already up there, so we don't need to write it again. All right. Okay, now we're gonna step it out. So we're gonna compare 1 3/8 and 1 2/3. So which benchmark could we use? Well, how about we use 1 1/2? Okay. So if I have 1 3/8 and 1 2/3, I'm not going to really worry about my whole. Why won't I worry about my whole number? Well, I don't need to because 1 whole is the same for all of them. So really, right now, I'm just comparing the fractions to 1/2. Okay? So, but we still need that 1 whole. So we are going to use this space. So I'm not going to do 1 whole and 1/2. I'm just telling you that right now. I'm just going to do the 1/2 because they all have 1 whole. So let's just compare the fractional part of our mixed number. Split it in half. And then I also need 1. Oops, it's super narrow, but that's okay. 3/8. So I can do half, half again, and then half again, because remember, an even denominator I can do that with. Now my 2/3 is not an even number. So 1/3, 2/3. Okay. So 1/2, obviously. So this is just the fractional part of my mixed number. My mixed number is 1 1/2. But I'm just comparing the fractional parts because the ones all are the same. 3/8. 1 3/8. And then 2/3. So if we compare these to our 1/2, we can see that 1 3/8 is less than 1 1/2. And we can see that 1 2/3 is greater than 1 1/2. So if this is the case, that means that 1 3/8 is less than 1 2/3 because 1 3/8 is less than 1/2 and 1 2/3 is greater than 1/2. Okay? Alrighty. Alright, so let's get out of that here. This is a little frustrating for me because we haven't worked on how to break apart these fractions yet. This isn't something that has been taught. It was supposed to be taught in 3rd grade, but you guys had part of a school year. So I'm going to quickly show you that if I have a bigger number as my numerator than my denominator, that means I'm going to have 1 whole plus a fraction, because 4/4 is the same as 1 whole. And if I were to break this apart, I would have 4/4 and 1/4. So if I change this, this is called an improper fraction. I'm going to change it to a proper fraction. So it actually ends up being a mixed number, 1 1/4. Okay, so that's the strawberries. And then the raspberries, we have 7/8. So if I have 7/8, do I have bigger than 1 whole? No, because my top number is smaller than my bottom number. So already I can look at these. If I have 1 whole and 1/4, that is bigger than just a 7/8. Because I have a whole pint plus I need 1/4 of a pint. This one I just need 7/8 of a pint. So there are more strawberries than raspberries. And that's one thing you can look at. If the top number, if your numerator is bigger than your denominator, then that fraction, and then you have a fraction that has a numerator smaller than the denominator, then you automatically will know that those strawberries, or that number fraction, is bigger. But we can break it apart too, right? And we can see the difference. Oh, excuse me. So we're going to write greater than or less than for the comparison. So if I have 2/3 compared to 5/12, don't really give us a lot of space to write this. So we have 2/3 and 5/12. So I'm not going to compare them to 1/2. I'm just going to compare them to each other. 2/3, 5/12. So I got to make sure my rectangles are the same length. Okay. 2/3. I'm going to break this up into 3 pieces. And I'm going to shade in 2 of them. And then 5/12. I have an even number, so I can split it in half. And then half of 12 is 6. So I could do 3. And then I could split those in half. And now I should have 12ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I need to shade 1, 2, 3, 4, 5 of them. So if I look at this picture, I can see that 2/3 is greater than 5/12. So 2/3 is greater than 5/12. So now we've got 13/10 and 8/5. 13/10 and 8/5. Now if I look at these, I can see that both of my fractions, the numerator is bigger than my denominator. So that tells me that if I know that 10/10 is the same as 1 whole, and I take 10/10 out of my 13/10, I'm going to have 3/10 left. So 13/10 is the same as 1 and 3/10. My 8/5. I have a 5/5, which is my 1 whole, and 3/5. So this is the same as 1 whole and 3/5. Okay? So I'm going to compare. See how I'm going to have 1 whole, and then I'm going to compare just the fractional part. So 3/10 I'm going to break in half, and then I need 5 on either side. And then I'm going to shade in 3 of those. And then 3/5. And I'm going to shade in 3 of those. So this is quite obvious, right? Quite bigger. 8/5 is bigger than 3/10 because 1 and 3/5 is bigger than 1 and 3/10. So 8/5, so 13/10 is less than 8/5. All right, so again, we've got a mixed number. The 1 whole we're not going to worry about because it's the same. We need to just focus on the fraction. So I have 5/6 and 3/10. I'll draw my rectangles. I need to break my 5/6. I can go in half, and then I would need 3 on each side. My 10ths, break it in half, just like I did this one, but then I'm going to have 5 on each side. And then I'm going to shade 5 of these. And I'm going to shade 3 of these. So we can see obviously that 5/6 is bigger. So 1 and 5/6 is greater than 1 3/10. And that's easy to see also because 5/6 is almost 1 whole, whereas 3/10 is less than a half. So that is how we see that. All right, so we are at the on your own section. So you can again do this independently, or you can stay with me and do this with me. All right, so how do 5/12 and 3/5 compare? So we want to compare 5/12 with 3/5. Okay, we want to see how those two compare. So if I have, this is going to be for 5/12. This is going to be for 3/5. My 12ths I can split in half, and then I need 6 on each side. And I'm going to shade in 5 of them. 2, 3, 4. Shade up here. So I can see that's less than 1/2, right? Because that's where my half was. 3/5 I can't split in half, but I'm going to split this into 5 equal pieces. And then I need to shade in 3 of them. So I can see that this is greater than 1/2. So that means that 3/5 is bigger than 5/12. So 5/12 is less than 3/5. All right, so we have 11/12 and 6/5. Now I can look at this one without drawing a picture. Why? Because my 6 for my numerator is bigger than my 5 for my denominator. So this tells me that I have a 1 whole in here and a fraction. So like if I were to break this up, I would have 5/5 and 1/5. So that's the same as 1 and 1/5. Well, if I have over a whole and this is less than a whole, this has to be less than. So I don't even have to draw a picture for that one. All right. Again, I could look at these and I don't really need to draw a picture. 2, 6 is, if I were to draw a number line, 2, 6 is going to be down here, right? Less than a half. 5/8 is going to be over here. Because 5/8 is going to be closer to 1 whole. So 5/8 is bigger than 2, 6. All right, these two, both the numerators are bigger than the denominators. So if I were to take out 6, 6, I would have 5, 6 left. So I have 1 and 5, 6. If I were to take out 10 tenths, I would have 2 tenths left, which is 1 and 2 tenths. So look at just the fractional part. 5, 6 is almost another whole. 2 tenths is very close to 0, right? It's only just 2 ticks above the 0. So 11/6 must be greater than 12 tenths. Alrighty. Leisha times herself climbing the wall. Her first climb takes 5/12 minutes. Her second climb takes 6/10 minutes. Which climb takes less time? So we have 5/12, and 6/10. Well, if I think about 12ths, what is half of 12? Half of 12, is 6, right? So if I had this broken up into 12, 6/12 would be the same as 1/2, right? Because half of 12 is 6. So 5/12 would be somewhere over here. It would be just a little bit less than 1/2. Now, if I guess I could have done it down here because of the visual model. Now if I have 6, so here, I'm going to make this a little bit better. So I have 0, 1 whole, 1/2. So just like if I had my rectangle, right, and I split it in half, this time I'm going to use a number line. So if I have my 5/12, And I'm breaking this up into twelfths. Remember, 12 twelfths is the same as 1 whole. And we just said that 6 twelfths is the same as 1/2. So 5 twelfths would be somewhere here, right? Just a little bit less than a half. And if I have another number line for tenths, 0, 1 whole, 1/2. What is half of 10? Half of 10 is 5. So 5 tenths is the same as 1/2. I look at 6 tenths, it's going to be a little bit over here. So 5 twelfths is a little bit less than a half. 6 tenths is a little bit more than a half. So that means that 5 twelfths is less than 6 tenths. So the climb that takes the less time is 5 twelfths of a minute. So using a number line can sometimes be a huge help as well than drawing your rectangle. Okay? So independently, you are going to do 11.2. Again, you can do number lines. You can do rectangles to compare your fractions. Remember, if the numerator is bigger than the denominator, then it's going to be a mixed number, right? It's going to have a whole number and a fraction if your numerator is bigger than your denominator. So be paying attention to that. All right, and you're going to do the whole thing for 11.2. If you have any questions, please make sure you reach out. I will be available Monday, Tuesday, and Wednesday of this week to help you out. Thursday I won't be unavailable because it's the day before break, and we will all be leaving at 2 that day. And so I will be unavailable because it's right before break. But Monday, Tuesday, Wednesday, please get a hold of me. I'm happy to have a meeting with you and we can discuss this further. All right, I hope you guys have a fabulous vacation, and I will see you on April 13th. Enjoy. Bye.